Good morning, buongiorno a tutti e benvenuti a questo nuovo webinar di SRA Instruments. Oggi il nostro webinar è dedicato ai Viscosimetri VP 2100 di Cambridge Viscosity. In particolare come la misura accurata della viscosità può migliorare la produttività e ridurre gli sprechi nella produzione di inchiostri, vernici, colle, rivestimenti e oli lubrificanti. La presentazione di SRA, quindi la presentazione e l'introduzione del webinar, verrà fatta da Gianluca Astani, che è il nostro manager della divisione industriale. A seguire avremo poi invece la presentazione da parte di Cambridge Viscosity sulla tecnologia e sulle sue applicazioni da parte di Robert Segnatelli e Patrick Riley. A questo punto do e condivido il mio schermo con Gianluca per iniziare il nostro webinar. Grazie.
Grazie Laura. Ora. Ecco, dovreste vedere lo schermo, vero Laura?
Perfetto.
Ok, buongiorno a tutti, il mio nome è Gianluca Stani e sono responsabile della divisione industriale in SRA Instruments. Vi illustro brevemente, introduco il webinar di oggi e vi dico due parole di SRA Instruments. SRA Instruments è un gruppo italiano con una sede a Milano, a Cernusco sul Naviglio in particolare, e una sede in Francia, a Lione. Siamo un gruppo di poco più di 50 persone distribuite tra Italia e Francia e il nostro core business riguarda essenzialmente le tecniche di analisi basate sulla tecnologia gas cromatografica e di spettroscopia. Distribuiamo soluzioni, prodotti e abbiamo in Francia un sito di ricerca e di sviluppo su strumentazione da processo, strumentazione industriale. Questi sono alcuni esempi dei prodotti che produciamo in Francia, prodotti che vengono installati nel processo, nell'analisi in linea per le analisi di gas. Oltre a questo sviluppiamo anche software, nella maggior parte software cromatografici e software per il monitoraggio industriale. Essere Instruments si occupa dicevo, di strumentazione scientifica per i laboratori e per il processo industriale in diversi settori applicativi, in diversi mercati. L'ambientale, pensiamo all'acqua, ai terreni, all'aria, alla food analysis, all'industria chimica, alla petrolchimica, l'industria dell'energia, alla caratterizzazione dei materiali, quindi packaging o pensiamo alle plastiche, microplastiche, settore forense e anche il settore farmaceutico e medicale. SRA Instruments è un Premier Solution Partner di Agilent Technologies, quindi tutte le soluzioni che realizziamo hanno come base, quando parliamo di gas cromatografia, dell'hardware di Agilent Technologies. Oltre a questo grande marchio uniamo tutta una serie di prodotti, di tecnologie che distribuiamo direttamente in Italia, che servono per accessoriare la strumentazione Agilent per realizzare soluzioni ad hoc per risolvere applicazioni ben specifiche. Tra queste troviamo un marchio, un gruppo, che è il gruppo PAC, che rappresenta i prodotti e quelle soluzioni per l'industria del petrolio, dell'energia. Essenzialmente PAC è un gruppo che opera a livello globale e fornisce strumentazione avanguardia per il laboratorio e il processo industriale. Questo gruppo incorpora tutta una serie di brand che operano appunto nel settore dell'industria del petrolio. Noi in Italia distribuiamo dal 2000 oramai l'analytical controls, lo vedete in basso a destra, che sono tutta una serie di gas cromatografi allestiti per le analisi dei combustibili, analisi dei gas e in Italia abbiamo circa 170 analizzatori tra raffinerie e impianti petrolchimici. Poi ci sono tutta una serie di aziende che vanno dalle determinazioni chimico-fisiche di laboratorio e di processo. In basso a sinistra vedete la Cambridge Viscosity, che è poi l'azienda che vogliamo illustrarvi oggi con il suo prodotto di punta, che è il Visco Pro 2100. La presentazione sarà fatta da Rob Segnatelli, che già dal cognome capite quanto gli sia simpatico il nostro paese, che è il responsabile dell'Europa, del nostro settore geografico, e ci presenterà questo prodotto, quindi dalla tecnologia a come è costruito e quali sono le applicazioni. Sotto vedete anche le mie indirizzo email, e per qualsiasi domanda o richiesta applicativa potete scrivermi, oppure direttamente sul nostro sito trovate anche altri riferimenti e vi daremo poi tutte le informazioni di cui avete bisogno. Io ora passo lo schermo a Rob Segnatelli per la sua presentazione e ci sentiremo poi alla fine. Se avete domande potete usare la chat e alla fine della presentazione di Rob potremo farne rispondere a qualcuna direttamente con l'aiuto degli specialisti di Cambridge Viscosity. So Rob, I give you the screen. Okay.
Gianluca?
Yes, okay. We can listen you. So
Yeah.
you can start. Yes,
Great.
thank you.
You can see my presentation, correct?
Yes.
Wonderful. Good. Thank you very much. Good afternoon, everyone. My name is Robert Segnatelli. I am the sales manager for Europe. I've been with Cambridge for 1 year, and prior to that, I was with Brookfield in the viscosity field for 6 years. I'm here with Patrick Riley today. Patrick is our director of sales, and he's been with Cambridge Viscosity for 20 years. So I'd like to thank everyone for joining us. I hope you find this very beneficial, helpful, and useful. And I'd also like to thank our partners at SRA Instruments, Gianluca and his team, Lada and Sabrina. They've done a wonderful job preparing this and for us. So I'd like to begin with a short video that we developed, which really details the technology of our viscometers. We hope it answers a lot of your questions in advance. I could do this in real time and try to paint the picture, but the narrator in this video has a much better voice than mine. So let's go ahead and take a quick look at this video. It's a short video, but it does a very good job of detailing our technology.
At Cambridge Viscosity, our patented sensor technology sets us apart from other viscometer manufacturers, making us the worldwide leader in remote sample viscosity. Our online viscometers install directly into the process, either in-line or in-tank, providing the most up-to-date readings. With only one moving part, a piston is driven electromagnetically through the fluid inside the measurement chamber at a constant force. A deflector positioned over the piston moves fluid into the measurement chamber, while two coils move the piston back and forth. Proprietary circuitry analyzes the piston two-way travel time to measure absolute viscosity. An internal temperature detector senses actual temperature inside the measurement chamber The system can calculate temperature compensated viscosity, which increases its accuracy under the ever-changing environmental conditions for direct comparison with laboratory data. The electronics can also provide the current shear rate at the measured viscosity. Since all the parts that can become wet are made of stainless steel and the piston is in constant motion, the sampling area is continually scrubbed clean to prevent fouling. The system holds its calibration and requires little to no maintenance. It is insensitive to flow, vibration, particles, or entrained gas. Data from the sensor is processed in the electronics in accordance with ASTM D7483, providing correlation to ASTM D445. Measured data is displayed directly on the analyzer. Outputs are available in 4 to 20 milliamps and Modbus to allow customers access to information where they need it most. The user interface can be either hardwired or accessed on a smartphone via the wireless option. The UI allows for changes in settings, units, and calibrations, as well as downloading of the error log and data log. For more information about our viscosity measurement solutions, visit www.cambridgeviscosity.com.
Thank you. So, as I said, that narrator has a great voice, much better than mine. So that video can be accessed on PAC's YouTube channel. It can be found at Cambridge Viscosity's website, cambridgeviscosity.com, and also on srainstruments.it, SRA Instruments website. So. Okay, so today we're going to cover a few different topics. We'll tell you a little bit about who we are and what we do in our technology and what makes our technology unique. We'll review the products that we offer. We'll take a look at some of the different applications that use our viscometers, and we'll show you some of our laboratory systems that are also used to support our process viscometer customers. So a little bit about Cambridge Viscosity. We were founded as Cambridge Applied Systems in 1984. That is Cambridge, Massachusetts, not Cambridge, England. Both are known for education, but we have schools here like Harvard and Massachusetts Institute of Technology, which is where our technology was originally developed. We're not quite sure what Cambridge Applied Systems was really focusing on other than viscosity. So we ended up changing our name to reflect our core business in 2006. And we joined PAC in 2012. So we're currently located in Boston, Massachusetts, which is right across the river from Cambridge. We're going to talk a little more about small sample viscosity in further detail. So we'll get to that in some slides. We have units in hundreds of applications around the world, and our technology is still under patent as we've continued to develop and improve our capabilities.
Hi, so Rob, thank you for the introduction. My name is Patrick Riley, and I'm the Director of Sales here at Cambridge Viscosity. And I'd like to tell you a little bit about our business. We consider our company to really operate in 4 main market segments, and then a number of other ones. But the 4 main ones would start with oil and gas exploration. So this is reservoir fluid analysis, where they're taking samples from downhole, and these are in very small volumes, and they're at very high temperatures and pressures. So measuring them is a specialty, and it's something that we've developed an instrument for, where We're kind of the gold standard. We probably have about 90% market share. And then lubricants. So in lubricants, we do a lot of oil condition monitoring. In refineries, these would be for compressors. Also, we do a number of specialty applications. So there's one in particular in Volkswagen in Germany where they use our viscometer to measure the lube oil health of lube oil that they use for stamping out parts, dyed parts like door panels. We're also widely used in test stands. These are research and development for the compressor manufacturers, companies like Hitachi, Honeywell, Atlas Copco, Carrier, where when they're developing new parts or new compressors, they use us for life cycle testing. And then we're also used widely in the design of new refrigerant mixtures. The next area where we play widely is coatings. One of our bigger applications there would be optical, as in converting and printing. Uniform coating is absolutely critical. They need to put the right amount of material on, or if they don't, they put too little on or too much on, it's not going to work properly. Some of the main companies that we work with would be like Luxottica or Transitions Optical. That's part of Essilor Group, and they are the company that makes the glasses that turn dark when they are exposed to sunlight. And there's a number of coatings that are put on these. These are anti-scratch coatings, anti-fog coatings, and of course the darkening agent. So these are often low volume applications. They're doing dip coating, and our viscometers are particularly suited to working in those low volume applications. And then medical devices for life sciences. Again, these are small volumes. When dealing with drug discovery, these can be less than a milliliter. These are working with proteins and doing things like, we hope, finding more vaccines and cures for COVID-19. With medical devices themselves, these would be things like stents, artificial valves, catheters, and subcutaneous syringes. All of these need to have very precisely controlled amounts of material applied to them for things like antimicrobial properties and especially lubricity, because if you don't slide them into the body correctly, there's going to be damage. So performance, again, applying the right amount of solids is absolutely critical for human health. And this is a significant portion of our business as well. And then we work in a number of other areas, hundreds of other areas. In beverage containers, these are things like the varnishes, the inside sprays, and the base coats that are applied to beverage cans. In aerospace, we work. Rob has been working on an application with NASA, the National Aeronautic and Space Administration here in the US, on an application where they're going to be putting a viscometer on the International Space Station, which we hope will be happening in the coming year, Rob?
About 1 year.
Right. And then in automotive alone, there's dozens of applications. These range from controlling the adhesives that are applied for the headliners that go in automobiles, for the specialty coatings that are applied in the headlamps. There's also just painting the cars themselves. So there's a number of things that we do around the world. But we've said this a few times, small sample viscosity. What do we mean by that? Well, when we look at the reservoir fluids, those are very small volumes that are available to test. And when we look at like drug discovery, those are very small volumes available. When we look at optical coatings or medical coatings, these are very low volume systems. The whole system might only be 8 liters or 5 liters. So you need to have something that can fit in there and measure with such small amounts of volumes available. So small sample is important for that. It's important where sample volume is limited, such as testing in drug discovery. It's important in processes where the volumes are low. It's important in processes where the lines are narrow. that doesn't mean that these can't be used in larger processes. We have these installed in 4-foot diameter pipelines. But being small, having compact sensors makes them much easier to pipe and plumb. And they don't require major piping changes. So that's another benefit. But also for maintaining or testing of the performance of these devices to test their accuracy, you need to just remove them from the line and put in a milliliter of fluid, and you can test their operation. Where with other types of technology, and you have a probe that is 30 centimeters long, the amount of expensive viscosity calibration testing oil is going to be required, is going to be significantly more, possibly a liter or more. So being small is very, very, very good thing in this industry. And we believe that we're doing big things in small places. So this is an image from the movie that you just watched, and that is showing us our 301 sensor there on the right-hand side. To give you some sense of scale, that sensor diameter is about 30 millimeters. And that piston that is moving up and down in the measurement chamber, that's about 8 millimeters. And the depth of that measurement chamber from top to bottom is approximately 25 millimeters. So this is a small, yes, and it's got a narrow gap. So that piston action pumping up and down is helping to exchange the fluid, right? As it moves up, fluid is being drawn underneath it, and it moves down, it displaces that fluid. That makes it self-cleaning because it's constantly scrubbing, okay? And we're not sensitive to vibrations, we're not sensitive to air bubbles and trained air, we're not sensitive to particles. What happens with particles is if they're too large, they can't come in, and if they're too small, they help constitute part of the viscosity of that fluid, and they just move in and out of the sensor. So something else I'd just like to highlight is the simplicity of the device and how rugged it is. This is basically a stainless steel cylinder where the piston is traveling. It's welded, closed at the bottom, and it's open to the process at the top. And it's wrapped in copper coils that are wrapped in another layer of 316 stainless steel. So this is rugged. There's nothing to break. This can be dropped, and that's not going to hurt it, and it won't affect the calibration. So it is a very reliable piece of equipment to have in your plant.
Okay, so just to quickly review the strengths of our technology. So the accuracy, we're very accurate. We are 1% of the reading, and repeatability, we are 0.5%. We comply to ASTM method D7483, and we correlate to within 1% of other methods like ASTM D445. Regarding the ruggedness of the sensor, as Patrick explained, it's welded 3/16 stainless steel with copper coils in there, so there's no moving parts. If you drop it, if you hit it with a piece of equipment, there's nothing in there to break. About the simplicity, you install the sensor into the line, you power the electronics, and then you start reading viscosity. So it's really intended to be a plug-and-play system. Very low maintenance. Ideally, it's intended to be no maintenance, but certainly there are some companies that have preventative maintenance plans that mandate that the sensors be cleaned every 3 months, every 6 months, every year. So it's very simple to remove the sensor. The 311 sensor, which is common in printing applications, just has a toolless clamp that holds the sensor in place. So there's a thumb screw. You can unscrew that, remove the clamp, pop the sensor right out, clean it, and put it back in. And that's going to take no more than 5 minutes at most. About the stability, how long do these hold calibration? How long do they need to be recalibrated? We found that the sensors, we pulled them out of lines after 10 years, and they are still within their 1% application accuracy specification. However, we do need to recommend some type of calibration check, and we have, because our customers request that, so we suggest doing that on an annual basis. So it's a very simple procedure to do a calibration verification of the instrument. And again, small size, that small sample volume and small size of the sensor makes it a very beneficial system. So we have a few different models of electronics, and most relevant to us here today would be the Visco Pro 2100. So the Visco Pro 2100 comes in two different flavors, if you will. The first on the left is a DIN rail mounted enclosure. So this could be mounted to a DIN rail on a wall or within a cabinet. The other enclosure that we offer is an explosion-proof enclosure. And this is class 1, zone 1 ATEX rated. And this is usually attached directly to the sensor. This is also good for outdoor use if the electronics will be exposed to the weather, because it is also weather tight. So you have the electronics, and then the other half of the equation is the sensors. So we have 6 300 series sensors on the left and 2 500 series sensors. The 300 series sensors, the diameters of the shaft are all the same, which is 30 millimeters. So really the difference of these sensors is how you would mount them in a process. So the 301 has a 1.25 inch NPT threaded connection. The 311, which is commonly used in inks and paints, has a quick release clamp with a 2-inch sanitary flange. And the 321, which is also used in inks and paints, is an in-tank sensor. So this could be inserted into a large tank, a 5-gallon bucket, or a 50-gallon drum.
Right, that would be inserted from the top.
Yes, that would be inserted directly through the top. The 372 is what we call our flow-through sensor. So there are 6 millimeter ports on each side, and the fluid actually flows through the sensor. There is a water jacket available for this if you wanted to thermally control the temperature. And this is very beneficial for where there's the process volume is low, such as Pat mentioned with the optics industry, when they only have about 8 liters of process fluid and the lines are low.
In medical coatings as well.
In medical coatings, yes, thank you. The 392 is one that is often used in marine applications to monitor the bunker fuel. And the 393 is one that is used, it's a very rugged sensor. So that's used in heavy industrial processes such as enhanced oil recovery, where they're injecting polymers downhole, offshore applications, and refineries. And there are a number of different flanges that are available for the 393 in 150 pound, 300 pound, 600 pound, and 900 pound ratings. The 501 and the 571 sensors are miniature sensors, if you will. These will fit in the palm of your hand. They're about the size of a 10-cent piece. They're about 12 millimeters in diameter, and these are used mostly in engines and compressor sumps, as well as test stands for compressor companies such as Carrier, Hitachi, Atlas Copco, and Danfoss. There's limited viscosity range that can be read with these due to their their small nature and a small gap. And with these, we can read up to 200 centipoise. With the 300 series, we can actually read up to 20,000 centipoise. There are no approval ratings for these, so these can be used in safe areas only. You would not want to use these in an explosive atmosphere. And 99% are used in R&D and life cycle testing. So they're really not exposed to explosive proof atmospheres. So all of these sensors can be paired with the Visco Pro 2100 DIN rail or explosion proof electronics. So there's a lot of different options that are available for the Visco Pro 2100. And we've actually developed a configuration guide to help you in selecting the correct components. So our configuration guide will guide you through selecting the correct configuration of your system. So there's really a number of different options here. So do you want to, your electronics, do you want DIN rail? Do you want explosion proof? The firmware package, what features are beneficial for you? Is your temperature low or a high temperature? So we can go up to 375 degrees Celsius. What area classification do you need? What sensor, process sensor do you need? Your viscosity range, and then there's a number of different options like your cable length. Would you like your wireless adapter so you can communicate to the device with your cell phone? Is there any hydrogen sulfide in the fluid? That would require a Hastelloy piston. So there's a lot of different options here that you can specify. And what this ultimately does is this will allow you to get a code that allows us to provide a quotation, that allow you to place an order, and in the future will allow you also to place to reorder the exact configuration. So there's a lot of information here, and you probably say, I need some more details, right? I want to know some more. So we actually have page 2 of this configuration guide, and this will give you details on the the mechanical dimensions of the electronics as well as the sensors. It'll detail the firmware options, and it will also tell you what area classifications are available for each sensor. So we hope that this configuration guide will answer 99% of your questions that you have. So one of the features that's available that I mentioned was, tying into the instrument using a wireless adapter. And to do this, you use what's called our web user interface. So I just really briefly want to take a look at explaining this feature of ours. So the web user interface allows you to connect to the Visco Pro 2100 to view live data, download log files, and change any configuration settings that are in the electronics. It has a fixed IP address that you simply need to type into a browser to connect. We have a wireless module that allows you to use your smartphone to connect to it, so you don't have to carry around your laptop throughout the plant while you're going to take a look at the processes. And it's also password protected to prevent users from making any unwanted changes. So I wanted to take a look at demonstrate how simple it is to connect. I'm not going to do this online because if I did, I need to connect to it wirelessly, and I would lose connection to our meeting, and then I'd just be talking to myself. So I just created a quick video on how this is accomplished. So let me go ahead and just start this really quick. So to start off with the wireless adapter, you search in your wireless network settings, and you will find the wireless adapter that's connected to the ViscoPro available there. So it's going to be called ViscoPro and then superseded by your serial number of the instrument. So you can select that and connect to the instrument. Then you can open up your web browser and simply type in the IP address. And again, for this, it's going to be 192.168.168.5. So that's a default setting, but if you wanted to change your IP address, you can most certainly do that. So as you enter the web UI, now we're connected to the ViscoPro 2100. Is a standard user, so you're limited on what you can access. But one of the things that you can do is you can take a look at the live measurements. So the live measurements will display the items such as viscosity, temperature, and other items that you have enabled, such as density or temperature compensated viscosity. It'll tell you the standard deviation of the reading, and it will also tell you the shear rate that the reading was taken at. So as a standard user, you can go in there and see these measurements live. There's also a system info screen as a user that allow you to go in there and access a number of files, one of which is the data log file. So you can click on the download data file, and then you could just simply open it up in Excel. So as you can see right here, the data in Excel contains the viscosity, temperature, the other enabled parameters, along with the date and time stamp. So that can be downloaded directly into Excel. So that's a very beneficial feature. So that's just for the users. You can then log in there as administrator, and you can make changes to the configuration of the system. So as you see, there's an additional screen there, configuration. So let's say, as an example, my ViscoPro 2100 had 3 different piston ranges in there. So I have a 1 to 20 and a 100 to 2000 range. So I wanted to change the piston. I wanted to do a different measurement range. So going through here, this allows you to set the different piston ranges. So this is one of the configuration settings. The other thing that you could do as an example is if you wanted to enable your temperature compensated viscosity. So that would allow you to go in here and put in your temperature compensated coefficient as well as your reference temperature. One other feature that would be available is if you wanted to rescale your 4 to 20 milliamp outputs. Again, these have 4 to 20 milliamp outputs for viscosity, temperature, and other enabled items. So you could do it for temperature compensated viscosity. So if you had a 10 to 200 piston range in there, as an example, your 4 to 20 milliamp would be scaled from 10 to 200. But if you know in actuality you were only going to be reading from 10 to 20 centipoise, you could rescale the 4 to 20 milliamp output to increase that scale for an increase in accuracy and resolution. So the web interface, again, it's one of the additional features that are available in the firmware options. It's very beneficial. It's very extensive. We could spend about an hour going through this, but just for the sake of time, I just wanted to give you a quick overview of that. So one of the things that we talked about was temperature compensated viscosity. So let's briefly discuss that next.
So temperature compensated viscosity, PCV. Temperatures are hard to maintain in industrial environments. They're going to change from day to day, from day to night. from summer to winter, from spring to fall. And things like presses can heat up over the course of the day, right? Or feedstock can be stored in an outside area or a different area of the plant where the temperatures are different. And so adding that to the print tanks can actually shock the system and cause big changes in viscosity. So low temperatures are going to make the viscosity higher. Higher temperature is going to make the viscosity lower, but you haven't actually changed the solids, right? And that's the whole goal here, to maintain constant solids so that you're applying them correctly to the process. So you need to reduce and eliminate temperature-induced error, right? And so TCV, or temperature compensated viscosity, which is based on an ASTM method, specifically method D341, defines how the fluid reacts to changes in temperatures, right? And we use a log-log equation to program this into the viscometer. And so this tells us what the viscosity would be at a fixed reference temperature. And we use that to control, right? So now if the temperature drops, the viscometer is not going to increase control and add more solvent to the process. It's going to be controlling on that temperature compensated viscosity number to ensure that it maintains the correct solids content of your ink or coating. So to summarize ViscoPro technology, it's got many benefits. It's rugged, it's reliable, it's self-cleaning, it's accurate, it's low maintenance, but you also get a lot of information from this device. We get the viscosity, right? It's in centipoise of centipoise, which is a dynamic viscosity measurement, but we can also provide it in other units of kinematic viscosity. You get the temperature with our built-in RTD. You get temperature compensated viscosity, so you can ensure that you have an accurate coat weight. Density, we have a patent on density for the viscometer as well. At this point, it has not traditionally been highly accurate. It's only been accurate to 2 decimal places. We believe that we've now got it to the point where it is 3 decimal places, and we have trials ongoing right now in Europe. And once they're complete, we will be able to update the density feature via a firmware patch. And then shear rate, right, which is important for non-Newtonian fluids to know how they're reacting to changes in viscosity as well. And this can happen with things like water-based coatings. So knowing the viscosity, the shear rate at the viscosity measurement is important for some customers. So there's a lot of information coming from this one small device. So just to talk about some of our key applications, specifically here, printing and converting. Our relationship with the printing industry goes back 20 years. We worked with a lot of larger companies in the United States who are running big operations. We've also worked with a number of the converters and press manufacturers globally, from PCMC and Cerruti, Flexotechnica, Soma, Heidelberg. Mostly we work in flexographic and rotogravure printing, though we do a number of other specialty printing applications for like temperature sensitive or photosensitive inks. So all of these have overlapping concerns, and the number one being quality. And also, you know, if you're investing in a device like this, to be able to get a return on investment based on material scrap. So, you know, a lot of quality issues are driven by inaccurate indicators like cup seconds, where there can be a variation of 4 seconds or more from operator to operator. And they're also driven by temperature fluctuations. So why have a lot of printers and converters switched to using ViscoPro? Well, it's easy to install. You put a T at the outlet of the mix tank, right? And that's it. You wire it back to the PLC. We have the signals that are required. We're doing temperature monitoring and TCV that allow us to filter out fluctuations that are induced into the system. And once you can filter out those variations, you can lay down consistent solids. These are low maintenance, self-cleaning, they're easy to maintain when you do maintain them, which I believe Rob's going to talk about at some point. And they have stable calibrations, so they're really ready to be in the industrial environments.
Great, thank you, Patrick. So just a quick overview of our laboratory analyzers, which are used to complement the customers with our process analyzers. We have our Viscolab 3000 and Viscolab 4000 and Viscolab PVT. So the Viscolab 3000 and 4000 use the same technology as are in the process instruments. So it uses the same, the piston, the same technology. So what that means is that you're able to duplicate readings from the process in a laboratory setting. So that's very important. It's going to apply the same shear rate to the materials, so you're going to be able to obtain consistent readings even for non-Newtonian fluids. The Viscolab 4000 is one that is used for ambient conditions. It does have a water jacket option, so if you wanted to thermally equilibrate the sample using a temperature-controlled water bath, you could do that, but most commonly it's just used at room temperature. The Viscolab 3000 has an integrated heating controller. So with that, you can go up to 180 degrees Celsius. So this is really used for, melting and high heat type of applications. Both of these can measure up to 20,000 centipoise, and both of these require very low sample volumes. So as you saw the sample chamber with the piston in there in minimal size. So that's why we are able to also measure these with less than 2 milliliters. The Viscolab PVT, that's one that is really not applicable towards the audience today. That is one that is used in the oil reservoir analysis, where they're spending millions of dollars to obtain a sample from deep below the earth, and they have limited sample volume. So with this system, one is able to measure under extremely high pressures, up to 30,000 PSI, and high temperatures as well, as up to 315 degrees C.
Yes.
So that wraps up our presentation. We did have quite an extensive presentation, but we went through it yesterday and it took us about 2 hours. So we decided to scale it back a little bit for the sake of time.
And we will be releasing some more technical information following this, such as case studies, return on investment numbers.
Yes, lessons learned.
Lessons learned, and it's some experience from customers that are related to printing and converting.
Thank you, Rob, and thank you, Pat, for your exhaustive explanation. Very, very clear. Ringrazio ovviamente Rob e Pat per la loro presentazione. Devo dire che quando ho conosciuto questi prodotti alcuni anni fa sono rimasto colpito essenzialmente da due aspetti. Uno è stato il principio di funzionamento, quindi la difficoltà che questo pistone incontra nel suo movimento longitudinale e poi funzione della viscosità del fluido. Aspetto ovviamente logico, ma devo dire intelligente come principio di funzionamento, e poi la compattezza e le dimensioni che questa tecnologia ha permesso di raggiungere. Avete visto numerosi sensori disponibili di diverse dimensioni, per diversi tipi di installazioni, diversi contesti. Ci sono sensori delle dimensioni di qualche centimetro, fino a sensori invece con dimensioni più importanti per delle installazioni su pipeline. La cosa importante è, proprio perché si parlava anche di low volume, quindi si può fare la misura con volumi anche contenuti di fluido, chi fa misura online lo comprende benissimo, l'importanza della rappresentatività del campione, quindi la facilità con cui il campione alla fine può andare a contatto con l'elemento sensibile, quindi con il sensore, per cui poter costruire questo principio di funzionamento in sensori di dimensioni compatti e piccolini permette di avere una misura alla fine affidabile. Io mi sono segnato una domanda che avevo visto in chat che riguarda ancora un po' la manutenzione, la facilità di pulizia, la facilità di installazione e la calibrazione, in quanto questi sensori arrivano dalla fabbrica calibrati, però la domanda è quanto poi frequentemente devono essere controllati o ricalibrati e questa operazione se può essere fatta direttamente sul campo, sul field e quanto complessa è. Rob, we have a question.
Yes.
And so what about, you already mentioned something about that, but about installation and maintenance, how easy is to install the sensor, to cleaning and maintenance the sensor? And again, related to the maintenance, how often you need to do the calibration? You say something during your presentation, but what means make a new calibration? It's something that can be done in the field?
Yeah, so I'll quickly answer the calibration question first. We recommend performing a calibration check once per year. So what that entails is removing the sensor from the system, cleaning it, adding a calibration fluid, and running it to ensure that the viscosity reading is at 1%, within 1% of the calibration fluid value. So these hold their calibration for a very long time. There's other types of viscometers up there, such as torsional or vibrational, which are needed to be checked much more frequently, as you know, the process conditions do affect their calibration. But it's a very simple process to do. We supply 30 milliliters of calibration fluid. You only need a couple milliliters to do that, so that calibration fluid will last a very long time. The other thing, Gianluca, that you can do is you can actually add an additional piston to the system. So let's say, as an example, you got a 1-to-20 piston, but you find out in the future that you need to measure a thicker fluid. So using that web user interface would allow you to calibrate a new piston to the viscometer using new calibration fluids to increase your measurement range.
Right, and that's those calibration menus are accessible in the user interface, and there are instructions in the manual for how to do a full factory calibration as we do it here, which is multi-point calibration, or there's another type of calibration in there, right? A field calibration.
Yes.
So that allows you to make an adjustment and an offset.
Yes.
In the event that there's something was off, you could adjust the calibration by just accessing the firmware.
Yep. Regarding how easy it is, I'll just show you really quick. This is our 3.1 sensor right here, and it's I'm sorry, 311 sensor, and it's mounted into a T.
That's the type of T that's typically used in the printing applications.
Okay, so this has the quick release clamp. So all one simply needs to do is unscrew this clamp here. So again, it's toolless, comes right off, and then your sensor is right here. Okay, so I'm trying to get with the webcam. So on the sensor itself, you have a block deflector. So that's simply removed, and that will give you access to the piston. So this block deflector remains in here so that the piston does not shoot out into the process line. It also works to divert flow into the sensor chamber itself.
Do you want to show them what a piston looks like while we're at it?
Nope.
Oh, you have one.
So once that's removed, the piston's right in there, it can slide right out. So that's the piston. And here's the sample chamber itself. So all you need to simply do is clean out this sample chamber, clean the piston, put everything back together, put that clamp on, and reinstall it into the, well, the clamp will be in the line actually. So just reinstall it back in the line, clamp it back up, and you're good to go. So from a maintenance standpoint, you know, that could take 5 minutes, and it's very simple to do.
Okay, and the sensor can be installed vertically, horizontally. There are some restrictions.
Yeah, well, we recommend from 9 o'clock to 3 o'clock. So
Okay.
one thing you would not want to do is to install it upside down. Okay, and in case there's any entrapped air bubbles in there or whatnot, if they're going to travel up, they might not be able to come out. In cases where there's some particles potentially in the fluid, you would want to do it horizontally. That'll allow the particles to flush out from the piston movement.
Okay, okay. This was another question regarding particle or bubble. I know that the system can tolerate particles, but there are also suggestions regarding installation, you say. So installing horizontally the sensor can prevent
accumulation of
accumulation of the
particles, right?
Okay, clear.
They'll just move out easier if the sensor is mounted horizontally.
Yeah, it's not a gravity trap.
Right.
Ok, clear. Non ci sono altre domande? Ok. Nessun'altra domanda, Laura. Mi è sembrato tutto abbastanza chiaro.
Sì,
Credo che
esatto.
abbiamo coperto un po' tutti i vari aspetti che riguardano sia l'applicazione, i principi di funzionamento e anche alcune informazioni utili per l'installazione.
From my side, I would like to thank you, Rob and Patrick, for joining us. Thank you for your enthusiastic and very professional presentation. So I hope that we will have the opportunity to do a new webinar in the future all together. So thank you again. A tutti voi io vi ringrazio tutti i partecipanti, anche grazie Gianluca, grazie anche a te.
No, grazie a tutti voi, grazie Laura, and thank you Rob and thank you Pat for your really presentation, very exhaustive presentation, and so thank you very much.
Good. Thank you once again for making the arrangements for this, and I'd also like to thank the audience for attending as well. We look forward to hearing from everyone. And I'd like to wish everyone a happy American Thanksgiving this week.
Yes.
Thank you.
We will be eating turkey. I hope you will as well.
We're eating it alone and not with our
Yes.
Right.
Vi ricordo che domani, una breve nota, riceverete tutti un'email di follow up con un certificato e seguiteci come sempre sui nostri canali su LinkedIn e sul nostro sito. Grazie ancora a tutti e arrivederci.
Grazie,
Bye.
grazie a tutti e arrivederci.
Mille grazie. Ciao.